The charge is the most fundamental entity in electromagnetic theory. The total charge in the universe is conserved. If one creates a positively charged particle, one also creates its antiparticle. Unlike mass fundamentally charges quantized, that is, it comes as a multiple of the most fundamental charge, that is, the charge of a single proton or electron. There are two polarities to charges, that is, a positive charge, defined as the charge measured inside an atomic nucleus, a charge of a proton, and a negative charge, defined as the charge of an electron. When a charge is placed in a free space, electric field E is generated, influencing all other charges in the vicinity. Electric fields radiate spherically outwards from positive charges inwards for negative charges. This is represented by flux lines pointing outwards or inwards respectively. Electric field is measured in volts per meter. In 1785, Charles Augustin de Coulomb proposed a physical law describing the force due to charges suspended in free space. Consider two charges Q1 and Q2 separated by a distance r. Coulomb's law states that there will be a force on Q1 due to the presence of Q2. This force is a vector quantity, whose direction is along the line connecting the charges, and whose magnitude is proportional to the product of the charges and inversely proportional to the square of the distance between them. It is an attractive force for charges of opposite signs and a repulsive force for charges of the same sign. Similarly to Newton's law of gravity, Coulomb's law is also an inverse r² law. Consider four charges placed in free space. The force on one of the charges due to three other charges is the vector sum of the three individual forces. Note that point charges do not act on themselves, only on other point charges. The proportionality constant in the law is known as Coulomb constant. Its value may depend on particular units being used. In SI units its value is 8.99 times 10 to the power 9 newtons meters squared over coulombs squared. Since the Coulomb force is always proportional to the charge on which it acts, we can instead use electric field, which is defined as force per unit charge. The electric field due to many charges is also the vector sum of all fields due to individual charges. We say that the electric field exists in space regardless of presence or absence of a test charge there. But to know if there is any electric field and to measure its magnitude and direction, one needs to place a test charge there, measure the force on it, and then divide the force by the value of that test charge. There is no other way. That is, the electric field does, it exerts the force on electric charges. It is also true that charges are the sole source of electric field. There is no other way to generate it.